So here we go. Welcome everyone. This is week 12. Yay! And we made it to the end of the semester, hopefully. And thank you, Adrian. And it's a weird setting, I know, because I actually, was looking forward to seeing you. And obviously, I don't see any of you, but that's okay. Well, I know you are there. To begin with, just a couple of words of well done, because I've noticed that all the group presentations have been submitted with plenty of time. So definitely there is no late submission penalty, which is great. So thank you all. We really now look forward to viewing your presentations. And I believe, but please don't quote me on this, that the marks for the group work is going to be released on the 22nd of January or something along those lines. So there is quite a while to go. The way in which this session is going to work is that I will start off with a few slides, of recap of what you're supposed to do for your individual report, which is now the last piece of assignment for data analysis. And then I will share the screen with you, and I will go through some of the most common variables in the ELSA dataset, how to deal with that, with those variables, how to deal with missing data, how to recode or categorize some of the variables. And obviously, you can ask all the questions you want. There is already one from Ash, who's saying, in the report, if we use logistic regression, it is enough to cover what we did in the practical session, or should we include other steps such as checking for outliers and multiple linearity? If so, do we use the same methods covered for multilinear regression? And thank you. So Ash, basically, yeah, no, you're not expected to do anything more than what you are covered in the module. So whatever was done at the practical session and at the lecture with Peter, that is more than enough. So don't feel like any of you actually have to go beyond all the content that we have covered in the module. I hope that answered the question, Ash. Okay. So, perfect. I assume you cannot, I forgot to check this completely. I hope you are hearing me, but obviously Ash replied, so at least one person is able to hear me. Oh, I think it's okay, it should be fine. Otherwise, people would have told me that they cannot hear a thing. Are we starting yet? So yeah, it's all good. So, having said that, a lot of what I'm about to cover in the next 10-15 minutes, I've already covered in week 7, at the previous recording. But maybe there are some new information, maybe not all of you have viewed that recording, so let's go quickly through what it is expected of you. So, this is the main part of your coursework. It's 80% of the assignment, of the marks for the module. And it involves this individual project. And by individual, obviously, I mean that you have to work on your own. Obviously, you can ask for advice from your friends and peers on the module, but obviously the idea and the content needs to be your own. Akash, get a rough word count for each section. I tend not to do that. I know that other modules do this, but you will see also in semester 2, not all modules do that. Also because it depends on the number of variables you're going to use, on the depth with which, for example, you address the literature review, so the introductory parts. So there isn't a very specific word count. What can I tell you is, and what I tell everybody actually, maximize the use of tables, because obviously those don't form part of the word count. So if a lot of information is included in tables, you will have much more kind of freedom to navigate the text in the different sections. Oh my God, now with the pronunciation of names, please forgive me in advance. NRA, oh my goodness. On writing the report, should we write it in 2 columns like those in the literature review, or should we write it normally? Absolutely normally. Normally, like you would do for any other assignment. So use just the full width of your A4 pages. So going back to this overview, you know that the word count is between 2,000 and 250 words and 2,750 words. So that would be the 2,500 plus or minus the allowed 10%. This count obviously excludes the table, the figures, your reference list, and the appendix. And that's why I was saying the more you can use tables, the more you will have opportunity to basically use the text allowance more freely. You are required to work on the ELSA Wave 7 dataset, which is your assessment dataset. The abstract is going to be included in the word count, and that is a guideline I can give you in terms of number of words. So a decent abstract is around 150 words. I wouldn't spend much more than that. But however, remember that it is structured, and we'll cover that in a couple of slides. And as I said, you must choose this ELSA dataset. What else am I saying? Oh, this is something different probably from the recording in week 7. I'm answering the questions as they come along, so probably this presentation is a bit distracted, but this is also why I wanted this format online, because see how many questions I'm already getting? I'm sure it wouldn't be the case if we were in a classroom. So Ling, can we use some other data in our report, like the number of population in England from ONS? No, it's just any potential variable you can find in the ELSA dataset, but that's the extent. So everyone starts and finishes on the same ground, so you are all assessed on the same data set. Z, can we use tools other than SPSS, like Excel, for data pre-processing, transformation? If SPSS is too difficult to perform some of the processes, transformation steps. Again, I mean, in the report, we only need to see SPSS. So if to confirm something or do, I don't know, a recoding or a transformation in another way, just to make sure that what you've done in SPSS makes sense, by all means, you can use Excel or other things, but we only need to see SPSS outputs. Carmen, to deal with the missing values in the ELSA dataset, is it okay to filter them out? Yes, it is. And this is something that I'm going to cover in the second part of this session. So as soon as I finish with this presentation, I will also cover the missing data. Okay, not a problem. Not a problem again. So let's see if, it's so weird. In a way, it's better because I'm really glad that you're asking all these questions, but I hope that the recording will make sense for the people who are not actually at the session. So step 1, the key points to remember, and I have 2-3 slides about these key points in order in which they more or less they should appear in the report. So first of all, for those of you who have not done this yet, identify what you want to do. So what are you interested in? I know in a lot of examples from the module we covered depression. You know that I have like a soft spot for depression. It's definitely a common topic, selected. So, but there are other possibilities. And again, in the second part of this recording, I'm going to give you some ideas potentially if you don't already have your own. Then what you need to do is select just one dependent or outcome variable that you want to assess, that you want to measure, and a subset of independent variable. And these independent variables shouldn't be a huge amount, because you always need to be mindful of the word count, which is not enormous. And here I'm saying 6 to 8. But if you have 5, or if you have, I don't know, 9, 10, that's fine. But don't go too much away from these guidelines. Basically, that's the suggestion that I'm giving you, because you will have to explain why you have selected these variables, in the sense that the justification for the selection of the independent variables needs to come from the literature. So you have looked at the, I don't know, various papers covering the topic that you have selected, and through these papers you should have formed an idea of the variables that make sense for you to answer your research question. In point 3, I'm saying make sure that you include some demographic variables, and I mention in particularly gender and age, because they're usually first of all, very informative, in the sense that they tend to produce some meaningful results from a statistical point of view, but also because it is an easy way forward, in the sense that you might be interested in looking at variations between of a certain aspect, again, depression, in terms of gender, or let's see if there are differences in terms of age. And it's always very good practice in a social science report, a social science study, to also include demographic characteristics of the sample that you are studying. Point number 4, start your results section with the descriptive statistics. If you remember from the module, we started off the first 3 lessons with this generic view of how to present data, the measure of central tendency, the measures of dispersions, and so on. And those are the foundation of your data analysis, because for you to be able to then move on to inferential statistics, you need to show that you know actually the data you're dealing with. So you need to show that you know your sample. And the best way to do that is through descriptive statistics. And again, this is standard practice in any publication in scientific literature that involves statistics. A little bit of description of the sample you are dealing with is always required. Point 5, use a combination of few inferential statistics depending on the research question you're asking. Now, funnily enough, the ELSA dataset is not that flexible, as I've been telling people who ask me questions about the reports in person, because there are a lot, I would say the vast majority, of categorical variables. So this limits, in reality, the number of the selection of statistical tools that you can use. Definitely something like a chi-square test, something like even Mann-Whitney or Kruskal-Wallis, which are obviously non-parametric, but they're also used in for ordinal categorical variables, are good way forwards. In terms of regression, unless you find a continuous outcome variable or dependent variable, the most plausible choice is actually binary logistic regression. Again, as I'm saying this again, in the second part of this recording, I'm showing you some examples of continuous variables, or also how you can create your own continuous variable. Because if you remember from the Nottingham study, so our training data set, some of the variables were composite. So the scientists who originated that data set also basically kind of manipulated the original variables, the original questions, to create new variables, which in nature became continuous. So it is limited, the ELSA data set per se, at face value, but there are also always some kinds of way forward if you are, I don't know, you are particularly keen on multiple linear regression, for example. So yes, basically, yeah, I'm blubbering, right? I'm saying a lot of things that probably you already know. Point number 6. Oh, that's it. Yeah, that's where I was going, actually, even without moving the slide forward. You don't have to include this form of regression. However, because the regression analysis we have covered are obviously the most complex form of analysis we covered in the module, it shows a learning growth. So you can do without, but the grade associated with your report obviously is going to be a reflection of this. So the grade you will get is not going to be particularly high. It might stay, I don't know, within the pass or merit bands, but it is very difficult that it might actually reach 70 or above. So this is, as I said, not compulsory, but I always suggest everyone to use some form of regression in your report. Sorry. To answer and to reiterate some of the questions that I already received here or via email from some of you, you can only use the techniques that you have learned on the module. Otherwise, what's the point of the module? So we need to make sure that what we taught you is actually what you're able to put in practice in the report. Point 8, once you have selected your variables, it is good practice to put them in a table. Okay. And I will show you this in the next couple of slides. Also for the sake of, maintaining some freedom with this word count, apart from that, it is good practice in scientific writing and in academic writing in general. Sorry, I actually also have a cold. Because it gives your reader, in this case, your markers, an immediate, visual impact with the set of variables that you have selected for your report. And here I'm suggesting what you should include in this table. Considering how user-unfriendly the ELSA dataset is, and to keep your markers calm, and me, first of all, calm, please include the variable name and label, because the name in itself is completely mysterious. I mean, it doesn't provide any information whatsoever. The label, what kind of dimension parameter it measures, the type of variable it is, whether it's categorical or continuous, and if it's categorical, obviously what kind of categories it includes. You can include this part, so this initial description of the variables, either in the methodology or at the beginning of the results before you carry out the descriptive statistics. If it was my own personal individual report, I would probably put it in the methodology, at the end of the methodology. Other points, okay, I didn't realize I had that many. 9, important in the ELSA data set, okay, the missing values are not coded, in the sense they are not excluded. So you need to remove them, basically. And I will show you the easiest, the fastest way of removing your missing values, which are all those negative codes, with some exceptions, and we'll see, because age is one of the exceptions. There is a negative code, but it's actually a category, just to make things easy or not confusing at all. Because if you don't do that, it's actually a very significant misconception. So in the sense, it shows that you really didn't grasp the meaning of the data set, the meaning of what we are trying to do, the fact that you need to clean your data before performing your analysis. So it shows a little bit of superficiality, which is going to be penalized seriously in terms of the grade that you will have in the end. Carmen, do we have to mention how we cleaned our data? No, there is no need, because I'm going to cover this now in I don't know, in the next half an hour or so. So don't worry about that. Point 10, make sure you have tables and figures within the report. This is a very, very typical mistake. Well, no mistake, probably it's just an oversight or something that students tend to have. You know, like you have the appendix to include, that is a compulsory part of your report. And in the past, I've seen students just referring the marker to, I don't know, such and such page in the appendix. No, first of all, it's really annoying scrolling up and down in your submission. But also, we are actually asking you explicitly to reformat the SPSS outputs, because a lot of output is not necessarily relevant to the interpretation of the results, for example. So again, you need to discriminate. You need to show quality of interpretation and data reporting rather than quantity. So the appendix can be as long as you want. I remember it was 2-3 years ago, there was one student who basically included 197 pages of SPSS report or something along those lines. So yeah, short of 200 pages of appendix, which is fine. I mean, knock yourself out by all means, but imagine the markers scrolling 200 pages. So no, we really don't want to do that. Jack, do we have to reformat all tables in both the body of the report and the appendix? Oh God, no, just the report. Seriously, otherwise what's the point of the appendix? Are we allowed to copy charts, graphs from SPSS? Yes, because those are already kind of formatted. So the purpose of this appendix is just playing in your favor. If you make a mistake, there is something not really quite matching in what you're saying and what you're reporting. It's something that us as marketers use to make sure that the actual output from SPSS is correct. So it could be a typo in the report. So it always plays in your favor. But you don't need to do anything else with the appendix apart from attach it there. Carmen, also, do we include the SPSS output syntax in the appendix? No, just the normal output, so the visual part. So when you have all the tables, so the output of your statistical tests. Yes, 11.11. Obviously, you must add the appendix, as I just said. So I just covered that. Point 12, use a good selection of citations in the introduction and discussion sections. Akash, just to confirm, copying graphs and charts is okay, just need to do tables from scratch. That is correct, because yeah, you can also manipulate a lot your charts and graphs in SPSS to make them almost as visually appealing as those of Excel. SPSS is not particularly great with graphics. But yeah, those are fine as they are produced in SPSS. The tables need to basically contain the information that is relevant, basically, to report the key outputs. Going back, to the citations. For a 2,500 word assignment, I tend to recommend at least 20. But this 20 is, to me, the bare minimum. Considering that they are not part of the word count, and obviously, yeah, you use the APA citation style, but even if you include a lot of citations within the text, that won't really impact on the word count. So show that you've done your research, show that you looked around the topic you have selected. Ideally, the vast majority of them, I would say more than 90%, should come from peer-reviewed articles, so from the scientific literature. And so you search your, oh my goodness, the university, oh, Star Plus, that's the database. You either use Star Plus or you start off with Google Scholar. I love Google Scholar because it is actually a very, very comprehensive database, and it has a very powerful algorithm underlying its searches. So it's perfectly appropriate, perfectly reliable, basically. Also because ideally, many of your resources, many of your citations should be as recent as possible. Again, to show that you know what's happening in that particular topic now, not what happened 20, 30 years ago, because we don't care, because things change. Like everything else in science, in research, the new research, new results come out all the time, and you need to show that you know what's happening now. Okay. Oh, this is an example of the table I was mentioning before. So your kind of summary table. And then just, I added a few variables. So imagine that you are doing this depression. So the factors affecting depression in elderly people in the UK, which is spot on, included in the ELSA dataset. So you have your variable name, which is HEP, whatever, this one, the horrible looking one. Then the variable label, which actually explains what this name stands for. What does it measure? Depression. What kind of variable it is? It's a categorical. Specifically, it's binary. If it's categorical, what kind of categories are included? There are just two categories because it's binary. So 0 for not mentioned and 1 for mentioned. And when it says mentioned or not mentioned, because I also got this question via email from several of you actually. When it's mentioned, we can safely assume that that person actually has been diagnosed with depression. If it's not mentioned, no, the person has no depression. And how are you planning to use your variable? As your dependent variable. Perfect. So this is what you do. Then imagine you want to include age as one of your demographic independent variables. Now, age is reported in this variable integer. And I'll show you how to work with this one, because this is the one in which there is a negative category, -7, which is to represent the people age 90 or above, which have been grouped in this category to avoid disclosure, so to avoid identification, which, okay, whatever. They decided that they needed to do that. But what I've seen last year was that a lot of students actually removed this category entirely. It is true that we have 9,666, I think, respondents. And the people aged 90 and above are only a handful. I think there are, let me see, I have written it somewhere. There are 193 people aged 90 and above. So it's a very small proportion of the data set, if you think about it. So in terms of the results of your analysis, it won't make a great deal of difference whether this group is included or not, but it's a conceptual error. So what is the rationale for excluding them? So again, if they're not included in your analysis, you'll be penalized, because how do you explain these 193 people missing? What have they done wrong to you? What do you have against them? See what I mean? So you need to work with those. How do you do that? Because this is a weird variable, you've got to recode that variable. And this might be the case in other variables you're going to use in your report. So you're going to change the nature of the integer variable into moving from a continuous variable, and which is it is a continuous variable to begin with, although they added this extra category, and you transform it into a proper full-on categorical variable. And I'll show you later on how to do that, so that you actually also include this 90 plus people, group of people, basically. What I'm reporting here is just an example of categorization, what I would do, but you can categorize in as many categories as you want, or as the literature you have read around your topic tends to do. Then you might want to cover the respondent sex, so another demographic variable. There are actually 3 sex variables in the data set. I'll show you where they are later on. This is already a categorical variable. Actually, this is a very nice, clean one, because it doesn't include any missing data. It's just 2 categories, 1 male, 2 female, very straightforward, very easy. Also, that's why I really like people using this variable, because it's easy and it's usually bearing a lot of good results. Olivia, yes, I'm getting there as well. I found 163 data age between 29 and 49, so I just removed the data. Yes, when you recategorize your integer, and you'll see it in a few minutes, I mean, in the next half an hour, whatever. Those 163 people automatically will be removed. The purpose of those people, I think, is to function as a pool for the subsequent waves, because obviously, considering that it's a longitudinal study, every time there is a new wave, the oldest people might die. It's blunt, but that's life. And so basically, they need to replenish at the other end, at the other extreme, so at the youngest part of the sample. And so there is this pool of younger people who are still interviewed, who are still part of the study, but who don't really actually, fit the age criteria. So definitely they need to be removed. Now, in this table here, I just color-coded the variable that I recoded in a different way. You can color-code it, you can do whatever you want, but in this summary table, it will be nice to have all the original variables, and in a way in which you want to visualize that, all the variables that you have also recoded for a reason or another, okay? And in the text, when you do that, a little bit of explanation as to why you have recorded certain variables would be very useful to understand your train of thoughts. Because, for example, here, as I said, the integer needs to be recorded. Otherwise, there is no way that you can perform an analysis with a variable that is half continuous, half categorical. So there is a very practical reason to do that, and to make sure that you include those I just said it, 193 people. So yeah, I hope it's making sense, but I see the questions coming. So if I need to go back to something, just drop me a question. Ash. I wanted to keep the age continuous, so I changed -7 to 90 and explained that I did this in its limitation. Not ideal, but I still captured those observations. Yes, well, the problem is you can do that, and yeah, I can accept your explanation. The fact is that all the people aged 90 or above could be 90, 91, 92, 93, could be 104. So if you just consider those as a block of 193 people aged 90, it might impact a little bit, because as I said, it's a tiny proportion of the data set. But it might, I don't know, slightly change, I don't know, if you do the binary logistic regression, the odds ratio for some of the variables in a tiny, tiny, tiny way. In principle, to cut it short, yes, you can do that. You can do that. If you explain this and report it as a limitation, feel free to do that. Also explain that considering it's such a small proportion of the data set, it shouldn't bear particularly significant changes to the actual results. Okay, moving on. Now, here in the next one, I'm just reporting a couple of examples of how you should present your results. And I think for this and the next table, it was Peter who covered those particular lessons. So this is a chi-square test result reporting, and with the text associated. Obviously, you have the slides and you have the recording, so I don't have to go through what it shows. You can do that in your own time. And this is an example of logistic regression, the binary logistic regression, that is. And because chances are, considering, as I said, the nature of this data set, that a lot of you will be using chi-square and binary logistic regression. So hence, the reason for reporting these two particular tables. Sections of the report, this I covered in the recording in week 7. Joe, wait a sec. Do we need to do correlation tests such as Pearson's or Pearson before doing regression, or scatter plots are enough? Scatter plots are enough, definitely, Joe, you don't need the regression. Both age and gender should be included, or either one is enough. No, either one. Actually, no. Again, this is not compulsory. It's just a suggestion because usually they give good results. So whatever works better for you, either one, both of them, neither of them, it's absolutely fine. Everything, no, a lot of the things I'm saying here are suggestions, apart the parts that I'm telling you to do for sure. And that's where we're getting at in this slide. So start off with the title. I know I said this, but every year there is someone falling for this. And every year there is someone not providing a title. You're halfway through the introduction thinking, what the hell is this talking about? So give a title. So if in your mind you formulate your research question, the title is just a simplification of that. So again, looking at the example of this depression that I love so much, if the research question is, by the way, you don't have to report the research question anywhere. The research question is something for you to think about, to create the skeleton of your report. But if what you're thinking about is, what are the factors influencing depression in older people? Fine, perfectly legal and acceptable research question. As a title, factors influencing depression in elderly people, or in older age in the UK, or among older people in the UK. So just keep it short, keep it snappy, informative. So from the title, we should be able to see what you're going to talk about. Also, in the title page, please remember to add the word count, obviously excluding all the parts that we discussed before, and your registration number. Do not include your name because this is an anonymous submission. And yeah, so if you don't include the word count, remember there is a 3 marks penalty. So make sure, and also there is a 3 marks penalty if you exceed the word count, either ends of the spectrum, whether it's too little or too much. So that's what I need to see in the title page. The title, word count, and registration number. Then we have the structured abstract. Daniel, would it be possible to code -9, -8, -2, and -1 recorded into new values such as 0? No answer. No, because they're actually missing data. They are missing data. So you cannot treat them in any other way, or otherwise, again, it will be a conceptual error. Structured abstract. These sections within parentheses are important. So introduction, in which you basically introduce the purpose of this this report. And it could be the fact that, you know, depression is one of those conditions affecting modern societies, and in particular the older generation, for such and such reasons. So you give a little bit of background. Theo, could it be possible to have a rough word distribution count for each of the sections of the report? Somebody else already asked for this, and I already said no, because it's very personal, considering the individual nature of your report, the number of variables you use, the way in which you manage to summarize your findings from the literature, or how many, I don't know, statistical analysis you want to conduct. So giving you a rough word count wouldn't be fair, because then knowing you is very prescriptive. So you would do whatever it takes to stay within those margins, and that's a mistake, because you need to have the freedom to think as a bloody scientist, like you are. And sorry for the use of word blood. Akash, or if you could tell us where the most words would be needed and where less words would be. So we are still going on with that. I can see you are hard to shake. Let's move on with this report sections, and let's see if you can get an idea. First of all, I shared with you the marking scheme, so you know what it is expected in each of the sections. So if you follow that marking scheme, and if you stand by the highest band, because that's the mark you want to achieve, then pretty much you know what you're supposed to do in each of the sections. So I'm still at this structured abstract. So introduction, aim. Aim could be just a line. So this the current report aims to address blah, 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 blah. Are you kidding me? Yeah, perhaps how much each section weighs. Oh my God. Oh my goodness me. Thank goodness I don't see you in person, or you don't see me. Okay, let's figure that out step by step. Introduction. Oh, no, sorry, still abstract. So aim, fairly straightforward. Methods, basically you describe the methodology. So this is a quantitative report in which, I don't know, chi-square tests, Mann-Whitney, and binary logistic regression has been adopted. Results, you will have a lot. Don't report all of them. Report the strongest. Easy. So the strongest from a statistical point of view, so in terms of probability, whatever. And basically, yeah, it's another 2, 3, 4 lines of text. And then your conclusions, which again provide a little bit of final context. So it shows that females tend to be more depressed than males. This has been, I don't know, also confirmed by the literature. And you can attend a little bit of interpretation as to why this is the case. So this is your abstract. Introduction to answer to Theo, Akash, and I can't remember the first one who asked this question. This is a very important section. So it weighs a lot, because it's where you show that you know what you're talking about in terms of the research area, the research topic you have selected. So you start off with, again, a little bit of background. Why it's important to do a specific piece of research, focusing on a specific topic. As I'm saying here, why it is important, why it's relevant, and so on. This can be actually, if you want, you don't have, you see the smaller bullet points, so the indented bullet points are suggested subsection titles. You don't have to really use them if you don't want, if it's too confusing. You can just use the introduction as your main section title, and then cover these aspects, the 3 bullet points within this one section. But it's important that you explain why the study is important, that you show that you have reviewed some recent literature, as I pointed out in the previous slides about the key points to remember. And at the end of this section, you should propose the aim and objectives. So the aim and objectives, the aim is basically why are you doing this research? So what are you aiming to do? What are you planning to do? And basically it describes the main goal or the overarching purpose of your research project. So it's the aim is the focal point of your research and provides your readers, well, your markers, that is, with clarity as to what your study is all about. Then the actual objectives are like a breaking down of the main aim. So they basically divide your aim into several smaller parts, each of which basically represent a key section of your research project. So the way in which it works, and obviously I'm sure if you read some literature already, you know that you have a sentence outlining your aim, and then you have a bunch of either numbered or bullet points underneath, which are your research objectives. If you cover 2, 3, 4 maximum, you would be fine. Just remember that they all need to start with what we call action verbs. Action verbs like to determine, to examine, to assess, to evaluate. So if you do a quick Google search about action verbs in research, you will find a huge list of these kind of verbs. And I want all your research objectives to be of this nature. So starting off with these kind of verbs. So going back to this depression that I like so much, this report aims to study the factors influencing depression in older people in the UK. Breakdown of the aims, of the aim, into the objectives could be objective 1, determine the relationship between depression and self-rated health, which might be one of the variables you have selected. Research objective 2, examine the influence of gender in a diagnosis of depression. Research objective 3, develop a prediction model of the key predictors of depression in elderly people. I would be absolutely delighted to see something along these lines. Okay, then you have your methods. Again, what I want to see here is 2 sub-elements. So explain what the ELSA is, with citations as well, because there are several studies covering what the ELSA is, why it's been created, and what it contains. And basically imagine that we as markers have no idea what the ELSA is. So in a couple of sentences, it doesn't have to take a lot of space. This is not particularly heavy in weight to answer Theo, but needs to be there. So what is this ELSA? What kind of study it involves, basically? What kind of aspects has been planned to analyze, and so on. And then the summary of data and statistical methods, like the table I just showed you, that's where it goes. So you can present your variables in a tabular format, and then underneath as text, you basically provide a bit of highlight. So the study obviously uses depression as the dependent variable, and such independent variables as have been selected based on the literature review. So you have to basically explain the variables presented in the table. And as I said before, if you are recoding some of the variables, that a little bit of explanation as to why and how you have recoded them is very much welcome in the text in this part. I forgot to mention this probably, yeah. All the figures, all the tables, all the graphs need a caption, like you do, like you see exactly in literature, in every paper. And each of these captions, so each of these tables, figures, charts, whatever, also needs to be linked to the text. So as shown in table 1 above, this research uses the, I don't know, depression variable as the outcome variable. So link your tables, all the images in your report to the actual text. Okay. Then the results, it's the fun part for a lot of people. And obviously here is where you have to reformat all the tables and produce, copy-paste basically the actual charts, if you want, from the SPSS output. And again, this is an important part, obviously very, very heavy in terms of weight, because here you need to show that the analyses are done properly. Is there any formatting to the tables? Well, no, it's entirely up to you, Jim, whatever. I tend to put all the captions below the tables, below the figures, just for consistency. If you decide to go above, knock yourself out, as long as they are there, basically. So no, I'm not fast, whatever. What was he saying? Oh gosh, I lost the train of thoughts. So we're in the results. Okay. In the results, this is an important part, so heavy in terms of marking, because you might know, or you might think that you know a statistical test, but there are a lot of little traps in each one, particularly, and I'm really stressing this, I know a lot of you are going to use the chi-square test. You know how many little rules there are around the nature of the cross-tabulation, the number of observed cases in each little square. You really need to make sure that you have considered all those aspects, because you might have a perfectly statistically significant result and you go, yay, but the cross-tabulation is actually invalid because a lot of the observed values is below the acceptable threshold. So the test doesn't mean anything because there are way too few participants or too few responses. So you really need to pay attention to the details and make sure that you actually report the correct probability value. So depending on the nature of the cross-tabulation, whether it's 2 by 2, 2 by 3, whether there are ordinal variables or not. So all those little rules that Peter covered in week 6. And obviously for each of these, so you start off with the descriptive statistics, and again, you will have a table, ideally, summarizing your descriptive statistics with a little bit of charts, if you want them, pie charts or bar charts or whatever is suitable. So you then describe in text, the highlights of the sample. So you can just say that there is a good gender split, if I'm not mistaken. I think it's 45 and 55, so it's very much ideal. So you just report the highlights, not every single point, because we can read, we see the table. You don't need to repeat. You don't need to repeat line by line what you already said. So again, discriminate what you think is the important information you want to relay within the text. And in this, again, the literature you will read should come in handy. Then for the inferential statistics, remember that you have to set up the null hypothesis and alternative hypothesis. You can do that as little tables. So you can start, I don't know, a subsection by saying chi-square tests or whatever, and at the top of each of your cross-tabulations, you can actually say in a little table, null hypothesis equals such and such, and below alternative hypothesis such and such. So that's another little bit of words saved. Daniel, for the description of the data, is it like brief explanation of variables? No, you have done that in the methodology. So it's now a little bit of explanation of the actual results. So as I said, if you have gender and you do the two proportions, so the two percentages, you can just say that the data set is fairly balanced because more or less there is an equal number of males and females. You can say the majority of these people are actually married. So you just report the highlights. If we have to summarize the values of the data in the summary table, do we need to explain the variables in the description of the data? Okay, I think I've answered that just now. So the summary table, the one in the methodology, is just for us markers to understand the nature of the variables you have selected. Then the table in the descriptive statistics is actually numerical. So you have done, I don't know, a frequency of, if it's a categorical variable, you do the frequency of each of the categories. If it's a continuous variable, you report the mean and the standard deviation. So it's different in nature, if that makes sense. Does it make sense, Daniel? I hope so. Well, yeah, it's always immediate. Okay, perfect. Thank you. No, it's not like in the classroom, just waiting for a person to nod. So yeah, okay, but thanks. Thank you for answering, Daniel. And again, in these results, you will have your descriptives. So you will have your outputs in tables formatted with the. If you want to add, I don't know, more diagrams, more figures, that's fine. You will have to explain what the results mean. So I need to see the interpretation of the results. It's not enough to say, oh, there is a statistically significant difference between, depression of women and depression of depression scores of women and depression scores of men. No, this is not enough because we are not idiots. We can see the output of the cross-tabulations, of the regression analysis. We need to see what do they mean, why they are there. So what are the implications? So particularly when you do, the binary logistic regression or any form of regression, really dedicate time and effort and words to explaining how each independent variable is affecting the dependent one, to what extent, learn how to report the odds ratio, and not just in percentage, but also, so that there is, females are 2.4 times more prone to be depressed than males, if I'm not mistaken. I think that was the result when we did it. So report this kind of detailed information, not just a repetition of what we can really see in the output. Okay. Discussion, another very heavy part of the report. So the three heavy parts of the report are the introduction, the results, and the discussion. Because in the discussion now you bring together your results and you compare them with the literature. And you compare and contrast. So as shown in, I don't know, Smith et al. 2022, females are indeed more depressed than males, and the explanation is blah, blah, blah. Here is the part where you can afford your own opinions, because these are your results. They still need to be kind of compared to the literature, but you can kind of venture a little bit of personal interpretation, which is something you cannot do in the introduction, because in the introduction, everything you say needs to be substantiated by the literature. Lakshmi, when referring to a study, do we add the reference in one format? No, you need to put the APA referencing style. So the APA referencing style includes, involves the author's surname. If you have up to 3 you include each of the 3 surnames, comma, year. If it's more than 3, it's Smith et al., comma, year. And again, in the reference list at the end, make sure that you follow the APA style, which is in hyperlink here in the slides. Otherwise, you'll be marked a little bit down. Not a lot, but a little bit. And every little helps, like Tesco. Conclusion, basically, again, you draw out the main results, not all of them, the strongest. And what is important is also that you mention the limitations, because every study has a limitation, every approach, every report has its own limitations. It could be in the number of cases you have in your variables. It could be in the fact that the research question you wanted to address didn't have the correct, the perfect variables, or you had to recode into a different one. So there are different, a lot, actually, there are a lot of potential limitations. And from the limitations, suggest future research. So if it was somebody else taking up your research after you have submitted it, what should they do? What should they look for? How should they expand or make it more, I don't know, comprehensive or more generalizable, and so on. Then references, as I said, in APA style, and the appendix, you just attach it to your document and upload everything as one document in Blackboard. We are almost there with this, because yes, that's the deadline, which is the 11th of January. I already said that, the addition of the word count in the title page. And do not put your name, and that's it. You can use your student registration number as the title of your submission if you want. I've seen so many variations. Again, this is not compulsory. It's just, for consistency, if you want to. I've seen so many titles of these files, and some of them very, very, very weird. But, well, there you go. So I hope this makes sense, because what I will do now is stop that. And, okay, another question, sorry. Joe, does the caption of table part of word count? No, it doesn't. I forgot to add that. Good question, Joe. No, it's not part of the word count. Fun. Will the video of this meeting be uploaded to Blackboard? Yes, because I know that the current PowerPoints on Blackboard seems to be different from today's. Really? Okay. I make sure that there is the coherent version of the PowerPoint. So there will be these slides that I've just shown you. And in the email I sent you on Wednesday, there is also the explanation of how to access the recording. Akash, how do we get word count to exclude all things not supposed to be included? Sorry, no, it's not obvious. To be honest, I don't know. If I do my own word count, I go section by section and then just add them manually. So I'm definitely not an automized kind of person. So find your way. I honestly don't have a good practice here. What I will do now, I share my screen. Let's see if you see the Elsa. Okay, and I'm still keeping an eye on the chat, because now what I want to do, I want to cover a few issues with this Elsa. First of all, again, something probably obvious, like you're saying, Akash, probably this is obvious for a lot of people. To search for a variable, what I tend to do is either going here to the label field and click on top so that the whole column is highlighted, and then select Control F, in which basically then I type, what am I interested in? Okay, depression, and then click on Find Next. Okay, there is one here, which is actually the correct one. And that's how I tend to look for variables in the data set. Missing data. Since we are here, let's cover the missing data right away. So you see, actually, the data set considers virtually basically all variables as continuous. You see the scale in the measure column, they're not. So you think, wow, I have all continuous variables. I can knock myself out and recode to my hard content. And no. You have just categorical variables with a lot of missing data. So here, for example, you have -9, -8, -2, and -1, which are kind of applicable to most of the variables. All these negative values are not good values. They are missing data. You cannot integrate them. You cannot recode them as zeros. No, you just need to get rid of them, or it is a mistake. So to do that, the easiest way is to go in the next column, so the missing column, this one. I lost it. I have to look for the variable again. Sorry, the flash. Okay, there it is. Put it up here. So you go to the next column, which is this one. Click on the side, and you have now this little dialog box showing up. To remove all of them in each of your variables, you have to select the range +1 optional discrete missing value and go from the low to the high. A step back. I'll get back here. Sorry. What I wanted to show you, if you don't, what happens if you don't remove the missing data? For each of your variables, I suggest you do a little bit of analyze, descriptive statistics, and descriptives, right? So imagine we are working with this depression, which is hepside. So let's see. I'm finding it. Hepside above. There it is. So like this, if you just click on OK, here already all your alarm bells should go crazy because you have the minimum and maximum, and you have a minimum of -9 and the maximum of 1. And you think, huh? No. That doesn't make sense. So there is already something wrong here. So this is the very first step I would take. Now, here you are and you think, oh, yeah, that's true. You see all those negatives, all -9, -8, and so on. Oh, I need to get rid of them. So go to the missing columns, select the range +1 optional discrete missing value. We don't care about that part. And we go from the low, which is our -9, to the high of our missing data ranges, which is the -1. And now you click on OK. And now, if you redo the same kind of analysis, obviously the descriptives is not particularly good because it's a binary. But if you redo the analysis now you see you have a minimum of 0 and the maximum of 1, which makes sense. So now you know that you are on track. Oh, you cannot see my output window. Okay, why? You're right. Why? Because it's a different window. Okay. If I share, I hate this bloody thing. So if I stop share this, and then I share the actual output. Okay. Okay. So I like to swap every time, basically. So the top descriptive statistic table is when we didn't remove the missing values. And so it doesn't make sense, the minimum and maximum. And the second one down here is the one after we removed the missing value. And you also see a lot of the variables actually don't have all respondents. So the fact that this one at the top says 9,666, that's already another alarm bell, because once you clean the data, you end up with 1011, which makes much more sense. There is another question from Laura. Sorry, I am Laura. Do we need to mention in the text that we filtered out these missing values? No, it's a given. The problem is if we see them. So no, don't waste your words on that. No worries. So now, blimey, do I have to go back to, yeah, let's go back to the actual data set. I'll have to do this on and off, on and off, on and off. So, okay, we are back here. Now, what I want to point your attention to is some variables that you might want to consider if you didn't come up already with a topic of some kind. And I'm going by a row. So the row, because it's easy, basically, it's just easier. One very common variable to use is the self-reported health. So in row 428, no, this one, the self-reported health. That's a very good one for you to use, which is, again, a categorical variable, very much similar to what we saw during the lessons. So there are also here 5 categories. You need to remove all these missing data, always, following the same procedure. Something I wanted to point your attention is the opposite the direction of these 5 categories, if that makes sense. If you remember from the Nottingham study, one was usually the category, the poorest category, the most negative category. So one was associated usually with low or bad values. No, here in the ELSA is actually the opposite. So 1 is our excellent health and 5 is our poor health. So when you remove these missing values and then you do, for example, a mean and standard deviation to get your descriptive statistics, you really need to understand what you're looking at, what you are interpreting. So always keep in mind the direction of these categories, because it plays tricks on the interpretation. To me, it's, I don't know, intuitive that the low categories, so the low codes 1, 2 are associated with bad things, because this is how I do my own research. And then when I got to know the ELSA, first of all, I thought, I've got to rewire my brain entirely, because it's all the other way around. So just please make sure that you keep this in mind. Something else I wanted to show you, the next ones, so 429, 430, and 31 are also other potential self-reported health variables. They tend to have less respondents. So if I had to choose my own for my own report, I would choose this one. So the HELF. So that's the good one to report. Another good one, all the way down, it's 6,124. Please tell me if what I'm covering is completely irrelevant to you, if you want to me to look at specific variables, because here I'm just going, according to the experience from last year. This is the life satisfaction. Life satisfaction could be a potentially good outcome variable, so dependent variable. Again, looking at this one, you have the same bunch of negative values to be removed, all of them. And then, because we like consistency in the ELSA, Now we have 7 categories, again, looking at the direction. So it goes from very, very positive in 1 to very, very negative in 7. If you want to use this one as your dependent variable, imagine, you cannot use it as it is, because obviously we didn't cover the ordinal logistic regression. We just covered the binary logistic regression or the multiple linear regression for continuous variables. So what do you do with this? You recode this. You recode it into a binary variable. And my suggestion is that you recode the positives, so all the agrees, as your 1 or 0, and all your negatives as your 1 or 2. So the other, basically, you select the 2 categories as 0 and 1 or as 1 and 2. It's entirely up to you. It doesn't make any difference. Because there are 7 categories, please make sure that you remove the central one, because it says by itself neither agree nor disagree. So there is no point in having this one. And this is another common mistake, because I have a lot of people asking me, oh, I have an odd number of categories. What do I do with the central one? On what side do I add it in? No side, because it's in the middle for a reason, to give respondents the opportunity to have no opinion. So in your analysis, you need to remove that as well when you recode it. If you use it as independent variable, that's absolutely fine. You can leave the 7 categories, and that's okay. If you want to slim down your analysis also from an independent variable point of view, you can still recode it as a binary if you want. It's entirely up to you. We are definitely not fast about this. So this is, as I said, a good one. Around this one, there are other potentially, good life satisfactions variables. So we have this one. In most ways, his or her life is close to his or her ideal. The condition of his or her life are excellent. Or we also have all these ones, these 2 as well. So far has got the important things that they wanted in life. They would change almost nothing. So you either use this one, which is the most obvious and the richest in terms of respondents, or if you want, you can basically have all these 5 merged into one. So you create your own composite variable, if that makes sense. So again, this depends on the literature. If you find that a lot of articles actually mention aspects like having this, life goals being achieved, or people not wanting to change anything, you have an argument for basically merging these 5 variables into one. However, if you just decide to pick this one, it's absolutely fine. So don't feel pushed in a direction or another. 2 other very, very, very important variables, very much used and loved. 600, okay. Oh, no, too much. 679 and 680. These 2, anxiety and depression. So a lot of people tend to use just the depression, or a lot of people tend to use just the anxiety, or an equal number of people tend to use both. These are the good ones to use, because a very common mistake I saw last year, but this is again a conceptual mistake going on here. You want to see what are the factors influencing this depression. And depression is a condition usually associated with a diagnosis with some kind of deep-seated problems. Depression is not something that someone develops in the space of a week. Because what I've seen last year was that a lot of people, instead of using this one, used this one down here. 5,900, 5,951. Whether felt depressed much of the time during past week. Who cares? Who cares? This is just past week, last week. This is not a diagnosis of depression. This is not an ongoing condition that the person has. So anything that says last week, stay clear of it, because it's not a good variable to give you proper deep insights. Anything with past week. So weather could not get much going much of the time in past week. Again, no. You don't care about what happened last week. You want to have the general overview, the general picture of these people. Daniel, how about HESKA? Let's see. Ah, yeah, I know which one it is. I'll get there, yes, because it's the smoking, yes, and it's actually, I will look at the HESKD, which is the number of cigarettes smoked per day. Sorry, there is also a person with the hand raised, so I get there. I will cover that, Daniel. Ling, should we change the topic if the missing variables involved in our topic are too many, like the valid variables of depression only have about 1,000? No, 1,000 is okay, and that's also to answer Daniel in a way. I would be concerned if there are less than 1,000, because there are so many missing data throughout that if you just use the variables with a large number of respondents, you literally just use the gender and the marital status, because the demographic variables are the rich ones. Every other variable has a lot of missing data. So you cannot really cut it, you cannot be too choosy. So about 1,000 is fine. So I hope you got the point about not using anything that has to do, for example, a lot of people like the loneliness topic, and last year they came back with this one, where they felt lonely much of the time during past week. No, honestly, there is no value in any of these variables. Joe, is merging variables needed to be supported by the literature? Could you recommend minimum continuous range that should be good enough for multiple linear regression? You remember the SAD score? No, not the SAD scores. The 14 items index scale in the Nottingham study. So the number of conditions, so the objective health, if you wish. And that was a scale from 0 to 14. So I would say, and I will have to actually inform the other markers about this, anything with, more than 12 categories could be considered as continuous. This is seriously debatable. What I'm telling you is an incredible shortcut, but definitely anything above 12 is continuous, okay? Yes, on smoking. Is the variable level whether doctor or nurse advised to stop smoking good to suggest that the respondent do smoke? No, it's not. You go with the number of cigarettes per day, which I covered in a minute. Because every nurse suggests stop smoking. They suggest it to me every time, and they still smoke. So no, not particularly. It's not too effective. Okay, now I have my list of variables, you see, so I'm going in the order of my own script. I will get to the smoking. So if you want the depression and anxiety, use those two that I showed you upstairs. Before, what upstairs? Oh my goodness, I'm losing track. In rows 681 to 685, so let's go back up. 681, okay. To 685, so this one here, these are other psychiatric problems. If you want to look at the basically a more comprehensive list of psychosis, again, you can merge the whole range. The whole range. Where am I? So anxiety, depression, all the way down here. And I don't think you still have a continuous variable because these are all binary variables. Joe, sorry, I don't think I answered. No, is merging variables needed to be supported by the literature? The merging per se, no, but in reading the literature, you will see whether papers consider, like in this case, other forms of psychiatric problems. So if you find that reading around depression leads you to consider also these other aspects, yeah, then you do it. Otherwise, you don't have to be particularly supported by the literature in this case. So no, if I answered, I hope. Best, if I want to include smoking tobacco to see its effect on anxiety, which variables should I include between variables 912, 913? Okay, let's see. 912, 912, where am I? Amount of tobacco smoke. To be honest, I use 111. I use this one always because that's how every time I go to the doctor, this is what they ask me. Do you smoke? Yes. How many? I'm not sharing this here, but basically they ask me for the actual number of cigarettes I smoke per day. Thank you for comparing. Just for clarification, it's possible to use upside as independent variable. Yeah, of course. Yeah. That's fine. So use this one. However, for this one, look at this. You still have to remove the missing values. You see, this is the cigarettes per day. So all the negative values are to be removed. Otherwise, again, you mess up the analysis, okay? So even if you see here, there is no range because it's a continuous variable. So sorry, there are no categories because it's a continuous variable. Still pay attention to the actual data because there are missing values also in the continuous variables, okay? Other variables, oh guys, we don't even have a break, but please bear with me because I know that this is important to you. So we have done the psychiatric problems. Some other variables that have been used in the past are from 743, so this one here, to 752 down here. So all the mobility problems, okay? Yes, 753. When I said that, no, okay, no, 2, because the last one, whether said had none of listed difficulties. So these are your mobility problems, and they can be merged. Again, let's see what are they in terms of, they're binary, again, they're binary with a lot of missing data. So they can be merged if you are looking at mobility aspects. So factors influencing mobility, for example, in elderly people. A good one, again, I'm going up and down here like a yo-yo. 6,088, 6088. 6088 here. These are some good life satisfaction ones. So we have this one. Sorry, no, I'm not moving it. And this one, and this one, and this one. So there are 4, which are very good to show social activities, basically structured social activities like going to the cinema, going to a restaurant, going to museum, galleries, concerts, opera, and so on. So these are also potentially interesting ones. And these are now, interestingly, you see they are categorical, again, not just binary. And we have 6 categories with all the very annoying negative missing data. So if you decide to go for these structured social activities, you can merge the 4 of them, and now you actually have a continuous variable, that go from 1 all the way to 24. Okay? Does it make sense? Once you have removed all your missing data. So that could be another option. Another one that people tend to use was the use of the internet. 6096, this one. Used it as dependent variable to show basically their engagement with technologies. If you decide to use this one as your dependent variable, you can categorize it into a binary one. So you have the frequent use of the email, so the first 3 items as your category 1, and then the least use, so categories 4, 5, and 6 as your category 2, basically. So that is another option. Life satisfaction, I already did life satisfaction. Yes, I did life satisfaction, okay. Loneliness is very close to life satisfaction because it's 6,127. So there it is. Life satisfactions, sorry, loneliness, what life? Loneliness, G. There are 4, so this is 1. Then the next one, how often responded felt left out. The next one as well. The next one as well. Or there is this one, which is basically the overarching loneliness variable. And this one is a, there isn't much you can do about this because it's a basically three categories. You cannot even recategorize it into what? Where do you put the sum of the time? Because this is not now a middle ground. This is just to say that people feel lonely some of the time. So if you want to use the loneliness, probably what I would do, I would again add all these 5 categories into to merge them into one and create a continuous variable, which is probably much easier. Just underneath here, all the CASP 19 variables, which have to do with the quality of life. Now, these are all categorical variables with 4 categories. And the CASP 19 is a very known international scale to measure the quality of life. And basically, if you decide to use them, again, the best course of action is to add them all up into one outcome, general quality of life variable, which now becomes your continuous dependent variable. And so you can use your multiple linear regression. So see what I mean? You have several options in the data set. As much as there are many continuous variables to begin with, you can create your own. And there are a few good options. Also close by here is the relationship with partner, for example. So we start here all the way down to 68. So this one all the way here. This is to assess the relationship of the respondent with their partner. So again, you can add them all up, and these are also categorical variables: very close, quite close, not very close, not at all close. And if you add them all up, you get your continuous variable. Other naturally presenting continuous variables, I only found very, very few. So there is 5959. I'm going a little faster. Oh God, it's not faster. G5959. This one here, the self-perceived age. So that's how old people feel rather than how old people are. If you go to this one, actually there are some negative values. You see the -1, the -8. So again, you really need to remove those. But this one could be fun to, I don't know if you find in the literature how perceived age can impact on, dementia, psychosis, quality of life. So there is scope to use this one because it's quite meaty in terms of number of respondents. So you might find something useful. Then there is the one about the state pension, row 2087. 2087. So this one here. How much is received from the state pension? Quite a few missing data. But again, this gives you the amount of pension per month. On the sex side, is sex a good variable to represent gender? I'll get there because there are three that show exactly the same. So there are three gender variables. Oh, no, in sex, gender, no, in gender. Okay, no. Yes, see. Yeah, gender, yes, it's one of the three. I'll get there. Give me a sec. Because it's the next one. It's the next batch I have in mind. Then there is this cigarettes smoked per day, which we saw it's 911. 911. There. And again, bunch of missing data, quite a few missing data. But if you want to study smoke, that's the best one. That is honestly the best one because this is really annoying. Whether reported in grams or ounces, no. If you want to do the tobacco use and smoking, this is the only one I would suggest anyone uses. Then I have some demographic variables. So age is one of them, integer age down here, which is 6346. Just at the bottom, integer. And see, it's -7, age of 90 or over, collapsed to avoid disclosure. No, you have to do this. You have to recategorize this one. Now, I don't want to sound patronizing. Do you want me to, before we move to the rest of the variables in the last 20 minutes, do you want me to recategorize this variable live? Okay, that was fast. Okay, so I guess if I do this, you cannot see anymore. No, so I have to stop sharing again. Okay, so this and share the new window. Okay, so here we are. the way in which you categorize a variable is by transforming it into a different variable. So transform, recode into different variable. And here you have your dialog box. Okay. So the variable we are looking at is age integer. So here, integer, there it is. We move it to the the output variable box, not the numeric variable box, and it tells me, okay, I have integer to begin with. What do I want to achieve? See the question mark. So you go to the output variable, and you could say age recoded as your name. I actually use the name and the label, the same thing. I don't have imagination. And click change. So now it has recorded that the new variable is going to be age underscore recorded. And then I go to all the new values, and I'm going to categorize it as I did it in the actual summary table, the example I just showed you in the slides. So we have range, people from 50 through 64, we give the value of 1 and add. Again, in range, people between 65 and 74, we give the new value of 2 and add. Range 75 through to 90, and we give the value of 3. And now, to include that -7, down here under value, we say -7, new value 4, and add. And continue, and OK. So now I have, sorry, to really stop sharing, because now it's in the actual, seriously, it's in the data file now. So, OK, down here now, you see you have the age recorded, 1. But remember that you have allocated those 4 categories, but what are they? So remember that you have to associate the value. So for value 1, the label is 50 to 64 years, if you want to really be comprehensive. 2 is 65 to 74 years, and that 3 is I said 75 to 90 years, and add, and 4 is greater than 90 years, and add, and OK, and remove the 2 decimal points which you don't need. And now, if you go to the analyze, descriptive statistics, and frequencies, and use the age recorded ones, and click on OK, you cannot see this. I'll show you. So let's, share the actual output. You see down here, now you have your 4 categories, including now the people aged 90 and above. And what you have missing from the system is those 175 people who are younger than 50 years. So you have your perfect recorded age, including all the relevant respondents, relevant cases in the data set. Okay, does it make sense? So let's stop sharing again this one and show the data set again. This is interesting. Okay, so here we are. Now we are at the actual gender. So funnily enough, gender, there are 3 variables, and they all show exactly the same thing. You can try in your own time. One of them is at the very top. of the data set, row 26, the age, sex. Again, actually, funnily enough, there are the negative, so the missing data, but there are no missing data. In these variables, the gender variable, there are actually no missing data whatsoever. So one is this one. The next one is called DI sex at row 400. This one, absolutely identical. And the third one is the IND sex, like you were saying, and that is 6,344. Ooh, too much. 344. And this one doesn't have actually any missing data, but all of them, once you do the the frequencies, you'll see that it gives exactly the same values. So you can use either one of the three. It doesn't make any difference to me. One final variable I wanted to show you, possibly with the recording live, is the marital status, because a lot of people tend to use the marital status. That is up here, 401, DMAR. This is a very nasty one in the sense that there are a lot of categories. See, look, there are 11 categories plus all the negative values. No wonder that SPSS considered this as a scale variable, so as a continuous variable. To be really, really precise and on the ball with this, you need to include all these categories. However, do you really want to use 11 categories in your, I don't know, cross-tabulation? Hell no, because you really go crazy. So you need to recode this one, ideally into a 3-4 category one. Do you want me to show the categorization of this one, or you think you can manage? Even one yes would suffice. If I don't, yeah, okay. Oh, thanks, Link. Off I go. So let me again stop sharing this one and share the actual output. Okay, so here we are. So same principle, we go to the transform menu and recode into different variable. We click on reset here because otherwise it remembers. And we go to DMAR. DMAR, close enough. DMAR, okay? And the new name could be marital no, status recorded. And copy paste to the label and change. Now, here we have 11 categories. So now, if you have your own screen or if you can access the data set, we have people who are single, people who are either in partnership or marriage, people who are separated or divorced, and people who are widowed. And then we have the last three categories, which include these categories I just mentioned, but in same-sex relationships, which again, they're even less than a handful of people, but they need to be included. Otherwise, what is the rationale for excluding them? So the single is only in one. It's actually value 1 in the original categories, and we just keep it as value 1 in the new category. Then we have all the people who are in partnership / marriage, imagine, and we have ranges here. So we go to range. For the heterosexual relationships is categories 2 to 4, and we give here the value of new value of 2. And for the same-sex one, we have category, actually not, the value of 11. But it's still people who are in partnership or marriage, so we still give the value of 2, okay? Then we have the people who are separated or divorced. And in the heterosexual ones, we have 6. Okay, I don't remember this one. 6 to 7, no, 6. I think it's 6. So it's actually a value. Oh my, I can't remember now. 6, and now we give the value of 3, and we click add. In the same-sex relationships, we have 8 and 9, so it's a range, and we still give the new value of 3. And then we have the people who are widow, which are category 4 in the heterosexual group. And here we can, category 7, what am I saying? Category 7 in the heterosexual group, and we give group value of 4, so the 4th category. And for the same sex, we have category 10, and we still give the new value of 4. Click add, click on continue, and click on OK. And stop sharing. Okay, and now share the actual data set. And again, this is now appearing as a new variable at the bottom of your data set. Remember, seriously, to remove the decimal points and to allocate the categories. So we said value 1 was our single and add. Value 2 was our partnership / marriage. There you go. Our value 3 was people separated / divorced. And our last category was widow. And okay. And now you have your new variable. Okay? One very, very final piece of information about another demographic variable is the ethnicity. Ethnicity is in row 5960. 5960. 5960 down here. There are many minor ethnic groups in the ELSA dataset, but they all account for a very, very small number of people. 98 plus something % of the ethnicity in the ELSA dataset is white. So if you decide to use the ethnicity, there are a lot of responses actually, because most respondents actually filled this part of the questionnaire, but it's a completely useless one because it's so unbalanced. So it's virtually all white, and you won't definitely get any valuable information out of this. So unfortunately, the ethnicity is one of those parameters that cannot be used. And with that, I finish. I just apply a little bit the slides, because I want you to do two things. And then I answer the questions as well. So first of all, guys, I sent you the email last Wednesday, Thursday, I can't remember, asking you to do the Tell Us survey. 37 did it, 37, I mean 70 didn't do it. Have we learned statistics or not? Do we want to show that we actually have the perfect record, the perfect, completion rate? Can you complete this survey for me? Yes, thank you. I don't want necessarily good feedback. I just want you to feedback in any possible way. So that's one, and you have this in the slides. And second, as usual, you have to do the attendance because this still counts as one of the things. So if you can please just take the photo of the QR code, that would be great. And I answer the questions. So on writing the results section, I didn't quite understand how to properly report stating the null and alternative hypothesis. Should we put them in tables and then describe our findings as text? Yeah, so basically, yeah, as I said, this is also a suggestion if you want to save words. So you can have a little, like 2-line table in which you have, the first box, say, HO, so null hypothesis, and then the actual text. There is no difference in the scores of depression between men and women. And then underneath the second line of this little table, H1, there is a statistically significant difference between the depression scores in males and females. Then you do your analysis, and then basically you interpret your results, and you start, and basically you say, and so after you have described your results, so we can reject the null hypothesis because actually females tend to be more depressed than males in a statistically significant fashion. So yeah, that's how I would do it. Supama, could you please show how to merge two variables, people who smoke and drink alcohol? Where are they? So people who smoke, I know where they are. So the 911. So okay, guys, do the attendance, because now I have to stop this. I need to, oh my gosh, stop sharing this one and reshare again the screen. Guys, but it's almost 3 minutes. This has been an intense day. No worry, Ling, my pleasure. So, share. So you said the smoking, which is 911. Ah, okay, 911, I should remember. So 911. And where is the alcohol? Apart from, no, you cannot merge. So this is already a continuous variable. You cannot merge potatoes with apples, if you know what I mean. So why should you want to merge alcohol and cigarette smoked? You wouldn't do that to begin with, if you know what I mean. However, looking at the example, one of the examples I was doing before, so the social activities, imagine 6,088. Sorry, I lost the chat for a second. I need to get there. 6,088. So here, let's see the chat. Loneliness. Ah, loneliness. Ah, lonely. Okay, let's do loneliness. Okay, fine. 6,127. So it would be, imagine you want to add all of them, right? That's what you want to see. So just let me jot down the name, SCFEELA to LE, because now I have to restop sharing this and share the actual output. Oh my goodness, output here. Okay. Okay, so you're here. You go to the transform menu again, to the compute variable, the one at the top. So you're looking at the loneliness ones. So it would be the SCF EE. Okay, so further down. So it would be this one. Bear in mind that first of all you have to remove all the negatives, so all the missing data. Okay, that's a given. So you start by, oh no, what did I do? So this one, put it in the numeric expression and then plus, You do that for each of the one. I'm missing steps. Plus D plus E, and this is basically your outcome, so the sum of all the 5 variables. You see, you still cannot click OK because you need to give the name of the target variable, which could be loneliness. And now you can click OK. And now what you have, and one final time, I stop this one and I share the actual output, data. And now once again, you see the new numerical value. And if you click, now this is, because I haven't removed the negatives, so now this one has the potential to become a continuous variable, but you need to remove all the negatives. So this is now a continuous loneliness variable. Okay, guys, it's 3 o'clock. I'm so sorry. I am 1 minute late. I hope it's all clear. I hope everything goes well with your individual reports. If you have any questions, please let me know. You are most welcome. It was a shame I couldn't see you, but it was nice chatting with you for another couple of hours. All the best to all of you. Okay, guys? Take care. Bye-bye. Bye, all.